Hello everyone. So in this video, I'm going to discuss about the quantum numbers. Okay. See, quantum numbers belong to the class 11th topic of chemistry. And this topic is generally difficult for the children. The children feel that this topic is difficult for them. But practically, this topic is one of the most easy topics of the class 11 syllabus. Okay. Before I discuss the quantum numbers, I would first like to tell you something about the quantum mechanical model of an atom. Now, according to the quantum mechanical model of atom, the electrons are present in the orbitals. Okay. And where do these orbitals exist? So, we need to understand this first. In the atom, you will have subshells, and in the shells, you have the subshells. Inside the subshells, there are the orbitals, and inside the orbitals, you have electrons. Okay, so this is a sequence which you need to remember while you are discussing the quantum numbers. Okay, so again I repeat, inside the atom, there are a lot of shells. In the shells, you will find many subshells. Inside the subshells, there will be so many orbitals, and in the orbitals, you will have electrons. Okay. In one particular orbital, you can have maximum 2 electrons. Okay. This thing you must remember, that in an orbital, only 2 electrons maximum can be present. Okay. Now to understand this sequence, I give you a simple example. For example, if you compare the atom with your school building, okay, you are comparing it with a school building. Now, inside the school building, there are lot of floors, okay, there are a lot of floors. Now, on the floors, there are the classrooms. You find the various classrooms on the floors. Now, in the classrooms, there are desks, and the students are sitting at the desk. Okay, so there are the students who are sitting at the desk. Maximum, how many students can sit? 2 students can sit. So you can relate the school building with atom. Inside the atom, there are shells, just like the school building has the floors. Inside the floors, you have the classrooms. Now, similarly, the shells will have the subshells. In the classrooms, you will find the desk. Similarly, the subshells will be having the orbitals. At the desk, only 2 students maximum can be seated. Similarly, in the orbitals, maximum 2 electrons can be present. Okay. Now, if I ask you that what is the location of the electron? So, for telling the complete location of the electron, you must have the knowledge of the orbital, the subshell, and the shell. Okay. Now, to represent the shell, subshell, orbitals, we use the simple numbers, and these numbers are called as quantum numbers. Okay. So, quantum numbers are the numbers which give you the information about the shell, subshell, orbital of what? Of the electron. Okay. So, every electron will have the set of quantum numbers. Okay. Now, which quantum numbers are these? There are 4 quantum numbers. Always remember, the first quantum number is the n. N is called the principal quantum number. Okay, this is principal quantum number. This quantum number represents the shells. The second quantum number is L. L is the azimuthal quantum number. Now, this azimuthal quantum number tells you about the subshells. Similarly, you have the next quantum number, which is ML. Okay, this quantum number is called the magnetic quantum number. Since I have written it below the orbitals, so obviously it means that it will represent the orbitals. And the fourth quantum number is the spin quantum number. ms is the spin quantum number, and this quantum number tells you about the direction of spinning of electron. The electron can spin in the clockwise direction or it can spin in the anti-clockwise direction. That means it can have the value plus half or it can have the value minus half. Plus half is the value when it is spinning in the clockwise direction, and minus half is the value when it is spinning in the anti-clockwise direction. Okay. So these four quantum numbers, these are giving you the complete information about the location of the electron. Okay, so these are principal quantum numbers. Principal quantum numbers, the first quantum number is a principal quantum number which tells you about the shells. Azimuthal quantum number tells you about the subshells. Magnetic quantum number tells you about the orbital, okay, orbital of the electron, and the spin quantum number tells you about the direction of spinning of electron. Okay. Now, for the better understanding of this topic, you need to remember these points. The first point is that L is equal to n minus 1. This you need to remember. Now, L is what? That is the azimuthal quantum number. And n is what? That is the principal quantum number. Okay. So, how you can learn it? See, you have seen that after the shell, the next location is subshell. Okay. So there is a difference of one step between the shell and subshell. Okay, subshell is one step down the shell. Okay, so when you do one step down the shell, why shell? Because this principal quantum number is actually representing the shell. Okay, so when you go one step down the shell, you get the subshell. Okay, so this way you can remember. Okay, and what are the possible values of n? The possible values of n are 1, 2, 3 and so on. Okay, it will go up to infinity. Now, the second important point is that for the value of L is equal to 0. Now, why I am writing the L value starting from 0? Because you have seen that n value will start from 1. Okay, and the value of L, it is always one step less than n. So if the first value of n is 1, then the first value of L should be 0. Okay, so when the value of L is 0, it means that the subshell is S. Okay, now when the value of L is 1, that means the subshell is P. Similarly, 2, subshell is D. 3, subshell is F, and 4, subshell is G. Okay, now these subshells have the particular shape also. Okay, every subshell has a particular shape. Okay, so this S subshell is what? That is of spherical shape. This is something important to remember. P is of dumbbell shape. D is of double dumbbell. And F and G, these two will have the complex shape. Okay. The next point to remember is that the value of ml is equal to minus L to plus L. Okay. That means its range is existing from minus L to plus L. See, magnetic quantum number is dependent on the value of L, because you can see that in the symbol of the magnetic quantum number, L is written in the subscript. Okay, so ml value will be dependent on the value of L. Now the symbol of L is made like this. You start with one point and you reach to the next point, and both the points are lying in the opposite direction. That means from minus L to plus L. So this way you can remember. Okay. Now the next is that if you want to calculate the number of orbitals in a shell, that means in a principal quantum number, the shell is obtained by the principal quantum number. Okay. Now the number of orbitals in a shell, if we wish to calculate, then we have to use the formula where we are using only the n symbol, okay, because we are calculating the orbitals from the shell, and shell is represented by n, okay. So the number of orbitals would be n square. So this is something important to remember. Likewise, if you calculate the number of orbitals in a subshell, so the symbol of subshell, you know, it is L, okay. So if you want to calculate the number of orbitals from the subshell, that means you have to use the value of L. Now the value of L is what? The value of L, you know, the complete range of L value, that is minus L to plus L, okay. I give you one example. If you talk about the s orbital or s subshell, we can say, if we are taking the s subshell, in the s subshell, the value of L, you can see that the value of L is 0. Okay, this is the 0 value for s subshell. This is a s subshell, the value of L is 0. So for the s subshell, the value of L is 0. For the p subshell, the value of L is 1. That means minus 1 to plus 1. I will write minus 1 to plus 1. Okay, now how many values I will be getting? Minus 1, 0 and plus 1. That means in total I will be having 3 orbitals. In the p subshell, I will be having 3 orbitals. Why? Because the orbitals I am calculating in the subshell from this formula. Okay, minus L to plus L. Okay, in s subshell, how many orbitals? Only one orbital. You will not say beta that it is 0 orbital. You have to count these values. Okay, you just have to count the number. So the number is just one value is given, that means one orbital. S subshell is having only one orbital. P subshell is having 3 orbitals. Okay, now D subshell, the D subshell value of L will vary from minus 2 to plus 2. That means minus 2, minus 1, 0, plus 1 and plus 2. So you will be having 5 values. That means there are how many orbitals? 5 orbitals. Okay, because you can see that you are having the 5 values. Similarly, in the F subshell, the value will lie from minus 3 to plus 3. So when you count all the numbers, you will be getting 7. So in the F subshell, you are having the 7 orbitals. Okay, so this is something important to remember. Okay, now we will be doing one question based on this quantum number so that you can check your understanding. This is a question where you are supposed to write the values of all quantum numbers for these orbitals 4d and 5f. So I have mentioned 2 orbitals and you have to mention the values of all 4 quantum numbers for the electrons lying in these orbitals. Okay. Now, the value of n is what? N is the shell. It represents the shell. How you get the shell? Shell is represented by this number, this digit which you see in the symbol of orbital. This digit is representing the principal quantum number. Okay, because shell is always 1, 2, 3, 4. These numbers are the shells. Okay, subshells are always S, P, D, F. Okay, so these are the subshells. So if I ask you that in the 4d orbital, what is the shell? That means 4 is a shell. Okay, and shell means the principal quantum number is 4. Now, if I ask you that what is the subshell here? Now, what is the subshell? Subshell is D. The name of the subshell is D. But as you can see here that for the D subshell, the value of L is 2. Okay, so you can write the value of L 2. Now, the next is ML. ML value, I have told you that ML value you always get from minus L to plus L. You can see this second point. In the second point, I have written that ML value is from minus L to plus L. So you will write minus 2 to plus 2. Okay. Now MS is the spin quantum number. That you also know that the spinning can have in two ways. So it can have the plus half value or the minus half value. Okay. Come to the next part. In the next part, the orbital is 5f. In the 5f orbital, the principal quantum number is 5 because 5 is the shell. Okay. Which is a subshell? Subshell is f. Okay. Now for the f subshell, you can see that I have written here for the f subshell, the value of L is 3. Okay. So the value of L is 3. I'm writing 3. Now again, for the value of ml, again you come to the second point. You see the second point which I have written. In the second point, I have clearly mentioned that the ml value you will get from minus L to plus L. Okay, so minus L to plus L means minus 3 to plus 3. Okay, and spin quantum number, again I will write plus half or minus half. Okay, beta. So I hope that you have understood this topic completely. And if you have the difficulty in any other topic, then you can write in the comment section. Thank you.